Okay, a warm welcome to everyone who's decided to join me today, and I am Preetham, and I'm going to take you through Python. So, yes, I promise you're going to learn something new today. You're at least going to know one more thing than you knew an hour before this. Alright, get ready, get your brain jogging, and more importantly, just grab a pencil or paper or a computer or anything that you can document things down so that you just don't listen to this like it's a fable. Alright, so, if we haven't met already, my name's Preetham and I'm a computer science major at Georgia State University. I'm also a freshman by grade. And you see, after this meeting, if you ever want to contact me, my contact information's up here with my phone number, my email, and you can message me on Discord too, or follow me on Instagram, please, and GitHub as well if you do have a GitHub, because I would definitely appreciate some GitHub followers. And if you enjoy cricket banter or like any memes about cricket, do follow me on Twitter because I post a lot of quotes that sometimes go viral and sometimes just don't. And if you ever want to talk about math or like any logic puzzles or like any interesting things, you can always message me. I would love to engage in conversations like that. I also play chess, so if you play, we should probably play someday. Alright, let's get started. So Python is an open source language which was invented in 1991 in Netherlands by a guy called Guido van Rossum. By open source, it means that people were able to readily make changes and write their own new libraries to it. And it is an interpreted language, which unlike other languages, this uses an interpreter which evaluates scripts line by line. A compiler is what evaluates scripts in Java. If you're in Java, and I know most of you are in 1301 or 1302 classes where you're learning about Java, but this is Python. And you are going to appreciate the beauty of Python even more if you have already had experience with a few other programming languages. So it could be Java, C++, C Sharp, C, or anything that has a strict syntax. Well, Python does have a strict syntax, but it's not as rigid as the other ones, and it's more closer to English. So almost everyone can understand that. And you gotta define methods and functions before you use them in Python, and Python is a part of the object-oriented programming languages family. Java is a part of this too, and one thing, not every script you write in Python, or not every command you write in Python needs to be executed, and it doesn't need to be in the main class program. Like, you could just execute some scripts like printing something. You don't have to write a main method like Java every time. Alright. So you can always install Python from that little link here, and it has different versions of different operating systems in there, so feel free to go reach that link. I've made it a little shorter for you in case you want to install that, so yes. Go ahead and download it whenever you can. And Python scripts can be run many different ways, and you can run them from your terminal. That's your command prompt or PowerShell or even the Mac terminal, or even Linux. Like any operating system can actually run Python scripts. And Jupyter Notebook or Jupyter Lab is one way you can run interactive Python scripts. That is when you can just see the output as soon as you define the variable, or when you call the name of the variable. Or last but not the least, you can get an IDE, which allows you to type Python scripts and does all the compiling. It's like more like an inbuilt set of instructions and structures. So I recommend against using an IDE because it will not serve you well in the long run, as you will not be able to remember the syntax and all the instructions that go one after the other. And as a computer scientist, you are supposed to be knowing them all. And you can't just get away with like saying, I don't know how this works, but I know the algorithm. Not many people like that. And yes, you can also run Python scripts using the interactive Python, which is, the interactive version, just like Jupyter, but this is a different one on your terminal. So Jupyter and IPython must be installed separately, but don't worry too much about it, because I am not going to show you any terminal or Jupyter or IPython today, because that's for a future lecture, depending on how you like this. Make sure to answer the survey at the end that I sent out to you guys. So yes, if you already have Python installed on your computer, good job. You can use a simple pip command to install Python. That is pip install IPython. I'm sorry, I meant to say IPython. My apologies. So yes, if you ever have any problems with installations, feel free to contact me, and make sure to run everything as an admin when you are installing things for the first time. Alright, and today I'm going to show you all the demos on an online interpreter called REPL.it, and you're going to love it. So the fulcrum of Python is the usage of white spaces, as it is what makes code very readable. If you've been programming in Java, you might realize that Java does not really care much about whether you use spaces or you don't, because everything's stored under braces. And as long as things are grouped under a set of opening and closed braces, it really doesn't care what the spacing is between them, as long as the end of a line has a semicolon. You could possibly write all the code on a line and it's still gonna take it. But I'm sorry, Python's not that way. You just gotta write every code, line after line. And you know one disadvantage of the white spacing? You are not going to be able to copy and paste Python code without problems. Like, should you ever try to, just borrow code from someone else, make sure to copy the spaces with it, because at any time you paste things without spaces and you just miss the indentations, Python's going to call you out big time on that. And yes, instead of braces, Python uses colons to separate blocks of code, and that's how it tells what lines of code go under which place. So let's move on. Python files are saved with the .py extension, just like Java files are saved with the .java extension. And before I forget, if you are looking to get an IDE, try Anaconda IDE out, because that gives you almost every tool you need to be successful. If you want to code in Python with data science or artificial intelligence, or if you want to go into any of those fields, you gotta know Python. And more importantly, it is one of the most beautiful languages. But again, Anaconda provides you with Jupyter inbuilt, and so does it with IPython, and you already have all the libraries downloaded too, so don't worry too much about them. And Python has this thing called dynamic typing, which means you really don't need to mention identifiers like int, double, float, string, boolean, or long, or anything that you would have to mention in other programming languages. Because if you type, you're going to see more of this when I show you the demos, but until then, just understand what dynamic typing is. Any questions so far? Okay, I'll take that as a no. And again, if you can overwrite variables with considerable ease in Python because it's dynamically typed, as I said. In Java, should you try to assign an integer to a string, it's going to call you up, but Python's not that. You can just assign anything to anything because the values get overwritten over and over again. Comments are supposed to be made in Python by using the pound symbol, or the hashtag, is what you guys call it. So these basically increase the readability of any set of codes. And more importantly, comments are useful to document and actually guide people through your code. Like if you're a retired IT professional or you just get fired, you will need to have comments in your code to tell people what they do, as you really don't want to write code that only you understand, as that would not help anyone. And although commenting may not look like a big issue in Python, but it will look like a big one when you use other languages like C or C++, where expressions and special characters, and it just gets all jumbled up because there is a lot of data and variables, expressions, and all characters jumbled together that it's not even close to English. You say, what gibberish is this? Now, yes, you can always comment things out when they don't work, because that's the safest thing to do while you debug. Alright, now that I've told you about some basics, now let me just show you some, okay. I will show you some demos. Let's go to REPL.it. Okay. Okay, it takes a while to open for some reason. Alright, there it is. Okay, so the first thing I'm going to show you in Python is a print statement. Give me a name, someone. Okay.
John.
Alright, thanks for volunteering, John. So I'm just going to print John. And you see the output there? It's going to print John. And as you might have noticed, Python does not require you to call the library in the parent class of this print function. Like in Java, I know you gotta write system.out.println, but in Python it's just print. And it does what it says. It is very simple. It just displays whatever you write in there to the console. Now, let me just comment that out because I will not be needing that for a while. Now, let's define a variable A. Alright, give me a numeric value for this.
N?
I'm sorry?
You said to give a numeric value, so
Yeah. I'm sorry.
10, I
Oh,
guess?
10. Alright. I'm sorry. My apologies. Couldn't catch that. Alright, another one.
6?
6. Perfect. So now what we're going to do is just some mathematical operations with these two numbers. Alright, so the first thing, I'm going to print the sum of these two. So, A plus B. I know what you guys think is going to happen is it's going to print 16, and that's exactly what it does there. As you see, A plus B, 10 plus 6 is 16. Now, similarly, I could use the difference operation. And I could take the difference of them both by performing subtraction. And now there, it's 4, because the difference between 10 and 6 is 4. Now I could multiply them both by using a star, and that would give me the product of them. Now these are the 4 arithmetic operations you must know, 3 arithmetic operations you must know. Another one is called division, and I wasn't going to miss that anyway. So this one is going to give you the quotient. It's not going to give you the remainder, but the remainder is a different story, so I'm going to show that to you in a little bit. And now 10 divided by 6, that's 1.6667. Can someone confirm that for me with a calculator? Okay. If REPL did it, it probably should be right. Alright, now that I've showed you the division, there is another feature of Python called integer division. Okay. Integer division only gives you the whole number part of the division. So, you're gonna see the difference, because now you see 1.667. But should I integer divide 10 and 6, I'm only going to get 1 because that floors the division. Floor is a mathematical term that is used to round the number down to the nearest smallest number. Now you're going to see the difference. The first thing you see is 1.667. That's when I conventionally divided 10 and 6. But when I integer divided them, the 1.667 gets rounded down to 1. And that's when I integer divided them. And now you must be wondering, what about the decimal point? What about the remainder? There is a way to find the remainder, and that is using the modulus operation of Python. So modulus operation is a percentage sign, which gives you the remainder. Yep. So now you're going to see that, print A mod B. So I'm going to give you the answer as a spoiler, because when you divide 10 and 6, 6 goes into 10 one time and leaves a remainder of 4. So you should expect to see a remainder of 4 right now. Right, there it is. Because the remainder of 10 and 6 divided is 4. And now, there's one last operation that I want to show you, but you probably will not use this a lot unless you are solving, a few math equations and possibly an infinite series. but this would be the exponent of a number. So now we have a 10 and 6, so that's going to be pretty easy to see. But if you want to implement an exponent, you got to implement it with a double star. This double star is just like multiplication, but not multiplication, as it multiplies the same number to itself, the number of times of the value to the right of it. So we're going to see that too. Now print A double star B. Now, what do you guys think is going to happen? Any guesses on the answer?
It'll be 10 to the 6th power.
Absolutely. Because the double star is not multiplication, it's an exponent. That raises A to B. Well, there is an alternate way you could do this using the math library, where you can get the math.pal function, but that would be the content of a future lecture. Alright, you see that is 10 raised to 6. Bingo. Now that I've showed you a few arithmetic operations, I'm going to show you a few logical operations. Now, logical operations consist of greater than, less than, greater than or equal to, less than or equal to, and then you have and, or, and then you have not and nor. Well, most of this is a part of propositional logic, but I'm going to show it to you anyway. So now, okay, is A greater than B? Yes. So it is supposed to return true, but let's check that out. A is greater than B. And now 10 is greater than 6, and that's true. So this returns true. And is A less than B? 10 is not less than B, so it's supposed to return false. And now 10, let's just change the value of B a little bit. Let's just make that 10 too. And now I can say A is less than or equal to. Keep in mind, this is a little different from the less than function, as this one checks if it is either less than or equal to the specific number. So 10 should be less than or equal to itself, and that is true, because 10 can be equal to itself. And now I can also change that to greater than or equal to, and 10 is not greater than itself, but it's definitely equal to itself, so this one's supposed to print out a true too. And we can always check another variation of this by using not, but that might be a little overkill for now. So now I will show you how to use an AND. In Java, that would be represented using a double ampersand, and an OR in Java would be represented using a double pipe, but that's not how you do it in Python. You can just write out the word and you'll see how. So A equals B. That is when I'm checking if A and B have the same value. If A and B, notice how I use the double equal to sign, because that is not the same thing as the assignment operator. If you use a single one, Python's going to assume that you are assigning the value of B to A. But now I've used the double, which means I'm comparing it. Now I can type in and then I can now just check if A is less than 20. So what do you think is going to happen here? What's this going to return? Okay, no responses, so I think it's going to return true, because A and B have the same value, and A is less than 20. They've both got to be true when you have an AND. And there you go, it's a true. Now, let's say A is greater than 20. Is 10 greater than 20? No, so this one's going to return a false. Now, I could change it to OR, which just needs any one of these to be true. A is equal to B. They both have the same value, so this one's going to return true. And then when you have A is less than or equal to 20, they are both true, so it is definitely going to return a true. And now, yes, that's it for the logical operations. Let's get back. So Python has libraries defined for almost every function you want to perform, or every operation or every application that you want to write almost. Let's say you want to build a game, a guessing game. Python has a random operation already defined for that. And then, as you're going to see towards the end of this lecture, there is a Hangman game that I have, and that uses the random operation too. And you would appreciate Python more as you had coded in languages that were not adequate, as you had to define your own modules and functions in there, but Python's not like that. It's got everything defined. And you can just import libraries using the import statement. Alright. Now that you know what the basics of it, you know how to perform operations, and you know what a variable is. Now let's just check if you can tell what kind of values a variable can hold, because like I said, Python is dynamically typed, and you might not always know what kind of values the variables hold. Okay, what's this glitch here? I'm not sure. Alright. Alright. Okay. Now you can always check what kind of variable what type of variable is by using the type function of Python. That's right here. You can just say type of the variable name. Now I'll just print the type of A, which should say integer, because 10 is an integer value. So now you have type of A. And run that. You're going to see int. Can you see that clearly? Or is there a blockage? Because I think I have a blockage in here. Does everyone see that clear?
No, there's like a blue line.
Okay. I'm not sure what's wrong with this. Let's try opening it up again. Okay. Alright. This one looks a little better. And it says, alright, it's loading. Yes. Now if I print the type of A, that's supposed to show me an integer because 10 is an integer. Now let's say I change A to 10.0. What do you think is going to happen? Is it still going to show me an integer? Any guesses?
Maybe float.
Oh, that sounds like a good guess. So let's check that out. Yes, you're right. It's a float. And now, let's say I change A to a string and say, hi, I am a string. Now, it's going to show me a string because A is a string, as it's a set of characters there. And we can try that for booleans and everything else, but let's try that later. You cannot concatenate two variables of the same type in Python because that is a strict rule of Python. You cannot concatenate an integer and a string, unlike Java, where you could just type the integer along with the string and it would just incorporate it to the string by converting it to a string. But in Python, you should manually convert the things to a string or an integer based on what you want, and you can use that using the string method of the string class and an int method of the integer class. You can do that for other data structures too, but you just got to use the name. And now there are 6 main types of scalar values in Python. Scalar values are just those that have a single type of value in Python, and there are 6 main types of those, which is integer, boolean, float, null, and bytes. An integer is basically all positive and negative counting numbers that range from -1 to negative infinity to positive infinity. They include the natural whole numbers, everything. But, a float is almost like an integer, except it takes every single decimal value. And then a string is just a collection of characters that can be alphanumeric or even contain special characters like a dollar, like an exclamation, or any punctuation mark. Now, don't read too much into the values, but I'm just going to give you a brief thing. And Booleans just have two main values. That is either true or false. Like, you've seen how I ran the Boolean values in the previous demo. And now, null values are values that are assigned with null and not been initialized yet. Bytes are basically the basic encoding of Python, where every string, every integer string, everything's encoded in a specific way. Don't read too much into it for now, and let's move on to strings. So Python is mainly used for the powerful string methods it has. And you could define a string using a single or double quotes, and you could always type whatever you want inside double quotes, and it's going to be a string. You could type 100 numbers, and that's going to be considered a string. A single or double quotes can be used interchangeably, and you could use one inside the other, but don't just use the other ones inside the others. You'll need escape sequences to actually pull that off. For multi-line strings, you would just need to repeat the quotes in triples. So you just got to hit each quote thrice, and there you're going to have a multi-line string ready. And you can type into it, and the main advantage of a multi-line string is that it can allow you to put in new space characters. You're gonna see that when I show you things, but let's just keep that in mind for now. And yeah, let's try it. So now here, as you see, I've defined a single line string with A, and I can just print A out. Now, hi, I am a string. That's a single line string, and you see, that prints the contents. Now, what if I change it to a double quotes? It's still going to be a single line, and do you think there's going to be any difference in the output? Let's find out. Here, there's no difference. Now, let me try to put new line characters in this, and say, this is the next line. Okay, what do you think's going to happen now? Any guesses? Any guesses, anyone?
An error?
Yes, it is going to throw an error because, you see, it reached the end of line. Because a single line string is not allowed to have new line characters. You should make sure that everything's in the same line. But should I just press delete and try printing that again, the error goes away because there's no new line character. But if I wanted to pull this off, I'll just need to define a couple more quotes there and press that 2 more times here. And I can, just press enter now. And again, I can go to the next line again and type this is the 3rd line. And now, should I run that? You see, there's a multi-line string. I can write a whole poem like that, a paragraph or anything I want using a multi-line string. And there's another useful attribute of this multi-line string. If you don't assign the multi-line string to any variable, it's just going to assume that's a comment. Just like the /* comment in Java, you can have multi-line comments in Python by just defining them as multi-line strings. Alright. Now that I've showed you what a string is, I can show you a few methods that strings have. So, give me another name. I'll just take Brion. Alright. I don't know, I just like the name. So, let's just print Brion to see that it's working. Yes, there you go. Did you know that you could also print a string as many times as you wanted in Python by simply saying what you want it to do? Alright. So, I'm just gonna say Brion times 50. What do you think's gonna happen now? Any guesses? Alright. No guesses? Okay, so should I run that, it's gonna print Brion 50 times. And you know, you can always scroll this way. I don't think I have that flexibility right now, but as you see, Breon's been printed 50 times with spaces. I know you can't do this in Java, because if you do that, it's going to say you can't multiply a string. And here you go, you can do that in Python. And ever wondered how you find the length of a string? I know in Java you have a str.length method. And Python has a similar method, except it's called len. And then you can just put len of b in brackets. And this would give me the number of characters in this, including the white space. So that should print out 6, because Breon is 5 letters long, and it's got a space. So yes, that's the length of the string. And now that you know the length of a string, you can do many operations with that. Like, let's say you wanted to, like, append this to somewhere else, or if you want to check there are enough spaces for you to put this, concatenate this with something. Or there are a wide range of applications for the length function of strings, and we'll get into them in possibly a future class. Alright, now I can always concatenate two strings by just using the plus operator. And since Breon is a good guy, and now it's gonna print Breon's a good guy because I just use a plus to concatenate them. I've joined two strings essentially. Keep in mind that strings are immutable, and you really can't change the original values of strings. Now that I've showed you how to concatenate things, I'm just going to comment this out, and I'll show you some more cool methods of strings. Have you ever wondered how you find the number of A's or B's or C's in a string? I know in Java you'll have to loop through the string, or like maybe there's an inbuilt method. Python's got an inbuilt method for that, and you don't need to... I'm sorry? Was that a question? Okay, was that a question? Okay, I assume that was not a question. So yes, you could always find the number... Let's take the string A and print the number of A's in there. The lowercase a's. So here, if I run that, I'm going to get a number, because there are just two A's. I am a string. There's one in am and one in a. And I can check the number of I's, or I can even check the number of times a specific word has come. I can check the number of times the line came in. So that would be 2 actually, because I've mentioned the line word twice. So a.count, str, the string.count function, tells you how many times the argument that you pass to it has occurred in there. Now that you've seen the count function, you're going to see another cool function in here, which is called replace. Anytime you want to quickly swap a couple of phrases, or you realize that you've typed them in the wrong place, you can always do it using the string.replace function, which is pretty simple. Replace. And this takes 2 arguments, and this generally it could take more depending on the number of times you want to replace it, but let's just stick to 2 for now. But this takes, let's say I want to replace line with replaced. And now it's going to replace every occurrence of line in here with replace. And you can see that when I run that, you say this is the next replace, this is the third replaced. The string.replace function allows you to replace one or more set of characters with a new set of characters. And if I completely wanted to delete them instead of, replacing them like that, I could always just say replace this with a blank space. A blank space is as good as a deleted string, and you'll see that the replaces just vanished now. This is the next line. Because, as I said, the strings are immutable. That's the reason you don't have the replace in here. Okay, now, have you ever wondered what to do when you've accidentally typed the whole essay in lowercase and don't know how to get it back? So there's a simple hack for that, and you could just use the string.upper, the .upper function, And let me just change everything to lowercase and a. So that, okay. No, not like that. And yeah. So we can always change the case of a specific string by using a simple .upper method. And it's going to capitalize every single thing inside this string, and you're going to see it. Oops, okay, I forgot the brackets. I thought it took it there. See, everything's capitalized. Now similarly, if I wanted to get it all to lowercase, I could just change it to lower. Okay, and now it's going to be the same as the string, but you get the point. It was uppercase, it became lowercase now. And now we can also change this to title case, where it capitalizes the first letter of every word. Like every single word here, you're gonna hear that in title case. You're gonna see that in title case, and let's just check that out. Okay, now I can just call the string.title function, and now you're gonna see the H, the I, the A, and every new word starts with a capital letter, with an uppercase letter. And now there is another cool feature of this, where you can find the index, or the first occurrence of a specific string or letter in a string. And you could just do that using the str.index function. Our string here is A, and now I can just type the specific thing I want to find inside A. Let's say I want to find the letter T. So when does that first occur? That should be in the first line, and at the 12th place. That's right here. And now I can also like type any word in there that I want to find, and that's still going to be the 12th place, the first occurrence of that, because that is on the first line. And now that it has index, now I will use string B now, because I want to show you another special feature of strings. Like, have you ever wondered how cool it would be to swap the case when you want to get into a sarcastic font, or whenever you type in messages? Right, you can do that using this function here called swap case. Any guesses on what's going to happen when I swap the case of B? Okay, anyone want to take a guess? Okay. Since I don't think
I think lower will become upper.
Okay, and?
Uppercase will become lowercase, maybe.
Alright, that sounds like a good assumption. You are taking away my thunder. Good job. That's exactly what happened, and it is exactly what it says. It swaps the case. If you're in lower, you go upper, and if you're upper, you go lower. Now that's a swap case entitled. And again, if you wanted to make it sound like you're screaming at someone, you could always change it to all caps. And you could also do that using the capitalize function. Okay, I will need to spell that a little better. There it is. And now I can print that. And you'll see the difference as the first word is just capitalized there. And now, for most of you in here, like, how would you reverse a string? Like, if I asked you to reverse the order of a string, how would you do that? It's okay if you're new to programming, but, you know, ideally, you would loop through the string and go in the reverse order and put it one by one. You know something Python does? It has this special function with strings where you could just reverse it by typing 8, 9 characters, depending on the length of the string. So it's the string name indexed with starting from -1 with a double colon. And to see what that does, I'm just gonna run that. It's the original string that I've run there and the reverse string. Because this just starts looking at the string from the opposite side. That is, it takes a white space as the first character and prints it all out. Alright, now that I've showed you this, that's it for strings, and let's move on. This is Boolean time. So, like I said, there are only two possible values for a Boolean in Python. They are either true or false. Like a Python string, you can pass anything in for a condition, and this will make sense more when we go over conditionals, but now, like, let's just take a 0. A 0 is considered false whenever it's passed to a condition, and this, you might know more about this when you like study assembly language, where a 0 is considered true and 1's considered false, but a 0 is considered false and 1's considered true. But in Python, a 0 is considered false and any non-zero positive number is considered true. So for this to make more sense, I'll show you a few conditionals now. Not conditionals, but since I've already showed you how the loops work, now we can also check print if b equals Brion. Now that should give you a true because b and Brion are the same. Now what if I just delete the white space? Any guesses about what's gonna happen? It's still the same name. Anyone?
Still the same, maybe?
Okay. It's still the same, maybe? Okay. Alas, it is not. Because this original string has a white space, and strings are literal. They take literally everything you put in there. Every white space, every number counts. And this one does not have a white space. And if it's inside a double quotes, it does not. It takes everything that's in there and compares it letter by letter. Now that we've seen that, there are two possible values of a Boolean. Again, it's true or false.
What if it's inside of single quotes?
Single quotes? Okay, like the original or this string. Okay, let's try single quotes. It doesn't make any difference because it's still false as there's no white space. But should I add the white space, it's going to turn to true. Right. To answer it?
Yes, you did. Thanks.
Okay. Yep. Alright, now that I showed you what a Boolean is, now it's time we look into conditionals. So conditionals are among the important parts in programming because you're inevitably going to run into conditionals every time you code. Because sometimes you just want to check if you want to do something only if something's true. And one of the most popular conditional statements is if. And if, just like an if in Java, takes a single or multiple conditions and evaluates them. And should they all turn out to be true, it executes a block of code under the if. And should they all turn out to be false, depending on whether you have an else block, like should you have an else block, it executes whatever's under the else. But if you don't have an else block, it just does nothing. Now sometimes you might have 2, 3, more, or even 10 conditions, and you may want to use something called an else if or an elif condition. That is where you can add an alternate condition and execute an alternate set of statements. That's basically a case-by-case evaluation of a condition. And this could also be done using a switch case. I'm sure many of you programming in Java must be familiar with this. You can always use ternary operators and the other things you use in JavaScript, but Python can do switch cases too, but we will cover that in a different lecture. And now, here's a sample of what an if and else statement looks like. You can see an if, there's a first condition. And should that be true, the first body is evaluated. And then there is an else, there is an elif. So that's a second condition. And if that's true, the second body gets evaluated. The same goes for the third condition in elif, and the third. And if nothing works out, the fourth condition is evaluated. Now, let me show you how an if works. Okay, we gotta define a couple of integer values now, too. Please give me a number. Okay,
12.
12. Yeah, I was thinking about 12, too. And another one?
20.
Alright, sounds good. Now, we can check if 12's greater than or equal to 20. Print this is a true condition. Now, let's see what happens when I run that. What do you guys think is going to happen? What's going to come out?
This is a true condition.
Are you sure? Okay, let's check that out.
Oh no, I'm tripping. I'm sorry.
Okay,
No, it's false.
it is false. Yes. And nothing's going to print out because I don't have an else block. And here, I can say else. Print the condition was false. And here, you're going to see the condition was false because 12 is not greater than or equal to 20. Now, I can add an or statement here where I can say b equals Brion with a space. Now, what do you think is going to happen now? Any guesses on what's going to print out? Well, let's find out.
Oh yeah.
Okay.
I think it's gonna be this is a true condition.
Yes, because that is exactly what comes out, because 12 is not greater than or equal to 20, but b is the same as Brion. Now, what if I change this to an and? What do you guys think is going to happen?
It'll be the condition was false.
Absolutely, because an and requires both the conditions to be true to evaluate the true, but an or just requires one. Alright? Okay, now I'll just show you an elif. Okay, let's say if a is, okay, if c is less than or equal to 12, print, okay, let's just make that d. Print, alright. You are not allowed to have an Instagram account. I'm not sure that's a rule, but let's just go by it for now. Elif, you know, d is less than 21, okay, or d is greater than 18, print, you know, you can have an Instagram account. And now else, lastly, I could say that, I could just say, you fall in the wrong age, you fall in the middle age group. Alright, middle age doesn't literally mean middle age, I mean it's between 13 and 18, right? Okay, let's run this. What do you think's gonna print out? Okay.
You can have a Instagram account.
Yes, because 20 is greater than 18. Now let's say I change that to 18. You know what's going to happen now? It's going to say that you will fall in the middle age group, because 18 is not greater than itself. It's only equal to itself. It can't be greater than or less than itself. Now that I've showed you what an elif does, let's move on to loops. Now, a loop is generally used when you want to repeat a specific process a few number of times. I know there are two main loops in Python, which is for and while. Although you can implement a do while too, but then the condition or the sentinel value will need to be defined early on if you want the loop to run at least once. So yes, today we are only gonna check for and while loops. Did you know that the loops are generally a combination of if-else statements that are stacked one after the other? Because they keep running only if a specific condition is true. Okay, now that I've told you what a loop is and how they're derived, let's check this. So for loops are generally used when you know how many times you want to run a specific process. Like if I told you to find the sum of numbers between 1 and 100, you know that this loop needs to run at least 100 times so that you can pass through every single number. And that is when you use a for loop. And now for loop can be done with iterables or even a range of values in some data structures, but we would go over the advanced uses of for loops in later lectures, based on how you like this. But yes, a range of numbers is easy to generate as you just define a for loop over a given bound. Like you have a lower and an upper bound with a specific stepping value as well. That generally comes in handy when you want to go through every n in a range. While loops are the other kind of loops that are used as long as you don't know how many times you're going to run the loop. Like if I told you to go through a file, or I told you to ask the user for an input, and you don't know, and he keeps entering an invalid input like a string to an integer or an integer to a string, like you want to keep prompting the user to enter the right value. Like tell him, hey, please enter the value. That's when you're going to use a while loop, because you don't know when he's about to stop playing around, right? And a while loop runs as long as a condition is true. But beware, if a condition is always true, you're in deep trouble, because that results in an infinite loop. And you generally don't want to run into situations like that, because they can get very messy to debug. So let's check out a specific for loop now. Okay, I'm just gonna make that a multi-line string and comment it out, because I don't want that coming in the way. Okay, now we have for I in range. Alright, let's start at 1 and go to 200. I can just say print I. What do you think is going to happen here? What's this going to do? Okay, let's just find out. Because this is going to print out every single number from 1 to 200. I put 201 because Python generally caps you off at 1 less than the target. Because if you enter an n as a second number, it's going to go up and until n minus 1. Okay, now let's keep going. As you can see, this has started from 1 and gone all the way to 200. It's printed every single number between 1 and 200. By number, I mean whole number. Now let's say I wanted to do just the odd numbers. I would just step it by 2. And now this is just going to start 1, 3, 5. And it's going to print every single odd number up and until 200. Which does not include 200 because 200 is even. So it stops off at 199. So that is a for loop for you. You can also do it in a string, and I'll show you how to do that. Okay, not in there. Wait. Yeah. Now, I can go for I in B, because this takes every single character in a string and prints it out. Print I. So, what do you think is going to happen now? How do you think you're going to see the output? Any ideas? No ideas? Alright, let's find out. You see, it's a letter by letter of this string. It's giving you a letter by letter breakdown of this string, including a white space at the end. that means it's looped through every single letter in the string and printed them out one after the other. Now, there is another kind of loop in here that's called a while loop, and this runs as long as a condition is true. So I'm going to show you how that works. While C is, greater than 9, or maybe 6, right? You want to print C, and I'm going to update the value of C by subtracting it by 1 every time. C minus equals 1, or C equals C minus 1. And now, should I run this, you're going to see all the numbers from 12 up and until 6, but not including 6, because 6 is not greater than 6. Alright, what do you think would happen if I would comment out this updating value of that? Any guesses? Any ideas? Like, I would not update the value.
It will be
I'm sorry?
infinite number of 12s.
Yes, absolutely, because C is not being modified, and it's going to keep going till eternity, so I'm just going to stop it right there. Alright. Yes, so that's an infinite loop you got to be careful about. Make sure that your condition is false at some time, or has a sentinel value that the user can always fall back on and stop the loop. Alright. Now that we've gone over that, I will need to show you two last magic statements in here. So, these two statements are the pass and break statements that you can just reduce the burden of the computer and make it perform less iterations. I know you would appreciate these two statements more once you know about algorithms and their runtime and the efficiency, but for now, they might look like nothing, but they are actually useful. As, the break abruptly stops the execution of the loop. It just tells the loop that that's it. This is it. Don't execute it anymore. And the pass is more like a placeholder statement that just tells the computer to do nothing. Like, don't perform any operation in here. Now, let me just show you how they work real quick. So, I can always do this while C is greater than 6. And then we will need to update this, or that's going to go into an infinite loop. And now, if C equals 7, right, I'm going to break this. C is greater than, C is greater than maybe 1. And this is when you're going to see you're going to appreciate this a lot more, because if it was 6, it would anyway stop at 7, and we would not be able to tell the difference of this break statement. And now, should I run this, what do you think is the last number you're going to see printed out there in the console? Any guesses on the last number? Okay, so let's find out. Now, you go 12, 11, 10, 9, and 8. And the moment C was equal to 7, because it just got decremented there, it just broke out. Like, the loop's not running anymore. But what happens when I change this to pass? That does not make a difference, as this loop is going to execute, like, to its conventional length until it was greater than 1. The moment it equaled 1, it just got out of it. Now, the pass is more like a placeholder statement that you will need to employ just to make sure that the loop's working, or just to reduce the burden of the computer at times. And now that I've showed you everything, please try to open this link on your computer, and we can actually play a game that I coded a few days ago. Okay, by the way, this game is what it sounds like. It's a hangman game. And are we ready?
Is there a link?
Yes. Right there. Do you want me to put that in the chat?
Yeah, that'll be helpful.
Okay. John, is there a way you can do that? Okay, wait up. Just put it in there.
We'll do that at the end.
I mean, they wanted to try it now. That's the reason.
Okay, then I'm gonna write it down. Give me a second.
Okay.
Show me the link again.
Okay. Just a minute. There.
All right, I got it.
Okay, did you put it in? Okay.
Yep.
Now, this one actually uses a lot of conditions, like I told you, and it uses a while loop to check if the user wants to still play. So let's just see what this does. Okay, let's guess the letter A. It's not in there. So any animal that is 5 letters and does not have an A, I know there are a lot, but okay, can we guess a letter now? Like any letter that is not A. E. Okay, so this animal's name ends with an E. And let's try I. Alright, that's... Okay, I've already guessed A. So I can try S. I can keep trying. And I can try an M. No, it doesn't exist. So, what's an animal's name that ends with an S and an E? Alright. Okay, I give up. So, the animal was a goose. Do you want to play again? You could always type a yes or a no, and if you type yes, it's going to go again. And here I can type E again, and D. Okay, I can keep guessing letters. I'm not sure I'm going to win this, but okay, I just got a double strike. Now, what could this animal be? Okay, I think it's an otter. Yes, it is an otter. I've guessed a word, and I do not want to play anymore. So, what this game really does is that it asks the user for an input to actually guess that. And every time you see a different picture, every time the user messes up. Like, it slowly becomes a man, and the man gets hanged when you finally, like, use up all the tries. Okay. Okay, you can always go ahead and try that at your own time, and here's some practice problems that you can work on. And we can discuss the solutions to them. Like, please do start working on these anytime. Take a screenshot or maybe write these down somewhere. And we can discuss them next time. Thank you for joining me today. And it's been a pleasure to actually go over Python like this. And see you next time.